All right, in this lesson here, we're going to be taking a look at arc length and area. We're going to start off with arc length of a circle. All right, so we already know what an arc is. So if you take a look at example 1 here, okay, an arc could be this piece right here. It's basically any part of a circle. Okay, we would want to find the length of that arc. That's what we're going to be doing here. We actually have a formula that helps us, and arc length is represented by lowercase s. Lowercase s. It actually, you might think of, why would arc length be represented by s? It's not even the same letter. Well, it's actually a Latin word, spatium. I don't know if I'm saying that right. Spatium, something like that, which is Latin for distance or space, length. Okay, so that's where they got that letter from. But pretty much it's used to represent length. It's also used for represent distance, but arc length is most commonly used, that lowercase s. All right, so we have this formula for arc length, and basically what the arc length is it's in degrees. It's all referencing back to circumference. We know that circumference, you're supposed to know that circumference is 2 pi r. Remember, circumference is the length around the entire circle. So that's if you have a 360-degree arc. A 360-degree arc is essentially the full circle, right? If we go all the way around, this circle, it's 360 degrees, and therefore 2 pi r, okay, 2 pi r would be the arc length. Circumference is the arc length. So if I don't go all the way around the circle, and in this case I only go 60 degrees around the circle, I'm only going 60 degrees of the circle, I'm just going to divide that by 360, like I have this in the formula here, and then multiply by 2 pi r. So it's what portion of the circle are we talking about? So in this case here, the angle's 60, so I'm going to go, so to find arc length, s equals, I'm going to go 60 over 360, and then just multiply that by 2 pi r. So times 2 pi, and then the radius is 5. So I have 2 times 5, which is 10, and times 60. 60 times 10 is 600. So I have 600 pi, and then over 360. 600 pi over 360, and that reduces down to 5 pi over 3, and that is our arc length. The length of the arc right here would be 5 pi over 3. If I want it in decimal form, okay, it would be 5.2. 5.2 centimeters. Okay, that is the length, how long, if I measured with a tape measure, how long this arc is. Here's another one. This time I have a 90-degree central angle, and so obviously I have a longer arc. So again, s equals, and it's going to be 90 out of 360. I'm going to calculate this one a different way. 2 times pi times 16. This one I'm going to do by simplifying the fraction first, just to show you it doesn't matter. 90 over 360 is 1/4. So it's 1/4 times 2 times 16, which is 32 pi. So basically this is 32 pi over 4, which is 8 pi. All right. So the length of this arc right here, if I take a tape measure and measured how long this was in centimeters, right, because my radius is in centimeters, so my arc length needs to be in centimeters, it would be 8 pi centimeters, or 25.1. Okay, 8 pi or 25.1, depending if they want it in terms of pi, an exact value, or if they wanted it to the nearest tenth, or rounded. 8 pi, you just put your calculator, 8 times pi. Pi is 3.14, right around there. So 8 times about 3.14 gives us 25.1. That's where that comes from. I did that ahead of time just to save you guys time. All right. Now, we're going to talk a little bit about radian measure here. And it's going to be difficult to understand, I think, the first time around in the video. And I think the more you do it, you'll understand it a little bit better. But basically, a radian, the A got cut off by the hole punch on your paper, I think. It's supposed to say a radian, right? A radian measures how far one radius will wrap around the circle. All right? So here's the length of the radius. This length right here, however long that is. If I copy that length onto the circle, like I did here. So see how this right here is the same length as the purple piece. It's purple on the, it's not purple on your paper, but it's purple on the screen there. Those are the same length, okay? From here to here is the same length as the center to here. When you have that situation, and obviously this is the same length, right? Because they're both radii. When you have the radius equal to the arc length, the length of the arc is the same as the length of the radius. That's 1 radian measure. That's a measure of 1 radian. So this angle, it's not 1 degree, right? Obviously, it's more than 1 degree. 1 degree is like this, right? 1 degree is real tiny. Radian measures are smaller measures. It's another way to measure an angle. You've seen radian before, right? We have to take our calculator out of radian mode to put it in degree mode. Well, now we're kind of learning what a radian is. A radian is when the length of the arc equals the radius. And that space right there, that angle, this angle right here is 1 radius. It turns out that you can do this about 6 times. So if I keep going, there's 1, right? Here's another 1. Okay? So this is 1 radius. This is another radius. Here's another radius, right? We're just breaking it up into equal pieces, and the equal pieces are the length of the radius. Here's another radius. Here's another radius. Here's another radius. Another one, and then you got a little piece left over. 1, 1, 1. So it doesn't matter how long the radius is. If the radius is 10, then each of those pieces are 10, 10, 10, 10, 10, 10, 10, right? If the radius is 400, then each of those pieces all around is 400 each. Okay, so it doesn't matter how big it is. So we're just calling it R, and then R, 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 all right? But it's 1, 2, 3, 4, 5, 6. And then a little bit left over. It's about 6.28. This piece right here is 0.28 radius, 0.28 of a radius, whatever that is. And that means that 2 pi, because 6.28 is 2 pi, right? 3.14 is approximately pi. So if I double that, it's about 6.28. That must be 2 pi, right? If I double 3.14, multiply it by 2, I multiply pi by 2, I get 2 pi. Around a full circle is going to be 2 pi radians. So 2 pi radians is equal to 360 degrees. And if you just cut that in half, right, you cut it in half, what's half of 360? Half of 360 is 180, and half of 2 pi is just 1 pi. So what we get from this little activity here, and that's only one circle, but it works with all circles, is that when you go all the way around the circle, it's 360 degrees, which we already know, and it's 2 pi radians, about 6.28 radians, or we call it 2 pi instead of saying 6.28, because 6.28 is an it's an estimate, it's rounded. 2 pi is exact, all right? And then 180 for degrees, half of the circle, is going to be pi radians. So we're going to talk more about radians in class, and as we finish up the course, we're going to talk a little about a little bit more. But I just want to show you what you're going to see on your formula sheet. This is on the formula sheet for your exam, your reference sheet. You'll see it. In fact, you guys have one, so if you have it with you, you can take a look. You'll see the conversion from radians to degrees. And again, it's based on this right here because 180 degrees is equal to 1 pi radians. 180 degrees is equal to pi radians. So 1 radian equals 180 divided by pi, and 1 degree is pi divided by 180. That's the different ways to convert radians to degrees and degrees to radians. So we'll talk more about that again. Arc length formula in radians. This is going to be our formula to find arc length if we're talking about radian measure. All right, in radian measure, we could find arc length. We're going to do that on the next page here. So let's say I want to find the arc length. Now, why is this different from our first example? In our first example, right, we were given, it's almost the same example right here, this A and then the one we're about to do. I was given the angle in degrees. It was 60 degrees. Now I'm given the angle in radians. Okay, pi over 3 is a radian measure. It is not in degrees. So if I have radians, I could simply do S equals R theta, or theta times R, same thing. S equals theta times R. Theta is the angle, which is pi over 3. That's a pi. And then the radius is 5. So S equals 5 pi over 3, which again is the same answer I got for example 1A because it's the same measurements. Pi over 3, 180 divided by, remember we said pi radians is about 180 degrees. 180 divided by 3, isn't that 60 degrees? So this is the same exact example as example 1, except instead of giving us 60 degrees, they gave us pi over 3. If they give it to us in radians, I can use this formula, which is much simpler. I can use S equals theta over R. What is the length of the arc if the circle has a radius of 10 and a central angle of 4 pi over 5? So same thing, S equals theta times R. S equals theta. Now theta is 4 pi over 5. And then the radius is 10. So that's going to be 40 pi over 5, which is going to be 8 pi. And then if you want to turn that into a decimal, it's about 25.1 centimeters. All right, so 8 pi or 25.1 centimeters. All right, a few more here. Now this one finds the measure of the angle, find the measure of the angle in radians, and they give us the arc length. So we can use the same formula, S equals theta R. This time S is 4 pi, the arc length is 4 pi, and the radius is 10. I don't know the angle, so it's theta times 10. So basically 4 pi equals, I'm just going over here now, 4 pi equals 10 times theta, and then divide by 10. Because that'll get theta by itself, so I'm solving for theta. 4 pi over 10 is 2 pi over 5 if you reduce it. And then if they want it in decimal form, it's going to be, I didn't do it in decimal form because we're not going to do these in decimal form. We're going to leave these in terms of pi. So my angle is 2 pi over 5 in radian measure. This one here wants me to find the arc length, and now I'm back to degrees. Okay, I'm back to degrees. So I'm going to go 162, S equals 162 out of 360, just switching gears again. Put it over 360 if it gives it to you in degrees, and then not equals, times 2 pi r, 2 pi r. So it's going to be 162 over 360 times 2 pi r. R is 15. All right, so it's basically 162 times 2 times 15 pi all over 360. That comes out to be 4860 pi. I did it ahead of time to save you time on the video. It's long enough. 4860 pi over 360. That reduces to 27 pi over 2. I just reduce the fraction, and then that comes out to be approximately 42.4 centimeters. And that would be our final answer. 42.4 centimeters, or 27 pi over 2 is the arc length. So just using these formulas here. Now, area is this, basically, we're going to do it the same way, area of a sector. So if I want to find the area of this sector, POR, area of a sector, that's going to be this area right here, the area of the circle. Well, remember, area of a circle is pi r squared. Area is pi r squared. But I don't want to find the entire area of the whole circle. I only want to find the area of this sector right here. Of this sector. Well, this sector is 162 degrees out of 360. That's what the formula does. It's 100, so area is 162 out of 360. And then instead of 2 pi r, because that's circumference, we just do pi r squared. R is 15. So we just do 162 out of 360 times pi r squared. R is 15. All right, so pretty basic here. This is going to be 36,000. Again, I did it ahead of time to save you time on the video. 36,450 pi over 360, which then breaks down to 405 pi over 4, which they could give you those, that is a choice in multiple choice, but then that goes down to 318 point, no, I just did 318, and it's squared centimeters. It's square centimeters because it's area. Area is square units. So again, multiply it out. You get 405 pi over 4. Just type that in your calculator. 405 pi divided by 4. You get 318 square centimeters. All right. We will work on arc length and radian measure and area in class tomorrow. Hopefully we'll get a little bit better at it and get a little bit better understanding. See you then.